In problem 3 of homework 9, we're going to conduct a lower tail test involving a population mean. In this problem, the average American drinks 21.6 gallons of milk per year. In this problem, you are assumed to be from the Midwest, and you believe milk consumption is at least this value. If milk consumption for the Midwestern town of Webster City is at least 21.6, then the null hypothesis is mu is greater than or equal to 21.6. Mu here is the unknown population mean milk consumption of Webster City. 21.6 is the claim from the Statistical Abstract of the United States. Now, if the null hypothesis is mu is greater than or equal to 21.6, then the alternative hypothesis is mu is less than 21.6. To estimate this mean, you have conducted a sample of 50 individuals from the town of Webster City. The mean from the sample is 22.11 gallons. Because we're assuming a standard deviation of 4.26, this is a sigma known problem. Now we're going to copy this information into Excel, and we'll come back and fill in the information later. The sample mean is 22.11, so I'm going to paste that right here next to X bar. The population standard deviation is 4.26. I'm going to paste that in next to sigma. The sample size is 50. The significance level is 5%. So I'm going to type in 0.05. This is a lower tail test since the alternative hypothesis says mu is less than 21.6. So we divide the alpha by 1. To find the z-value, we go to my teaching page and click on the PDF that corresponds to all the distribution tables. Now we can get the critical value, the negative critical value, from the standard normal table, but the standard normal table only produces z-values to 3 decimal places. So instead we go to the infinity row of the TE table, and we're going to be in column 0.05. So in column 0.05 and infinity row, we see the z critical value is 1.645, but since it's a lower tail test, we're going to make that negative. Now the variance of the variable is just the square of the population standard deviation. The variance of the sample mean is going to be smaller than the variance of the variable because we take the variance of the variable and divide by the sample size. The standard deviation of the sample mean, also known as the standard error of the mean, it is equal to the square root of the variance of the sample mean. The test statistic is just the point estimate of the difference between the population mean and its hypothesized value and the standard error. Now we're going to copy these values into Cengage Now. The first thing we're going to copy into Cengage Now is the critical value of the test, negative 1.645. The point estimate of the population mean is X bar, the sample mean. The point estimate of the difference between the hypothesized value and the point estimate of the population mean is 0.51. And all these two are to 2 decimal places. The standard error to 4 decimal places is 0.6025. The test statistic to 4 decimal places is 0.8465. To conclude in part G, we have to compare the test statistic to the critical value. Now, if the test statistic is less than the critical value, we have evidence in support of the alternative. Since that's not the case, we have evidence in support of the null. So we cannot reject the null, which means we cannot conclude that milk consumption in Webster City is less than the national average. I'm going to check my work, and we should get all green check marks. And we do.